In a previous video, we have already discussed how to solve exponential equations when there is one exponential term. Today, what I want to talk about is how to solve an exponential equation when there's two exponential terms. And basically, what that boils down to is we want to use what is called the one-to-one property. Now the idea with that is, let's say I gave you an equation like 2 to the x power equals 2 to the third power. And I just asked you to determine what x equals. Well, if you look at this and think about it for a minute or two, I think eventually you would be able to reach the answer just by common sense. Because what you would notice here is that both sides have an exponential term with a base of 2. And so if 2 to some power is supposed to equal 2 to the third power, well, with the 2's, with the bases being exactly the same, the only way those can be equal to each other is if the exponents are also exactly the same. And that's basically what the one-to-one property says. What it says is, if we have a single term on each side of the equation, and their bases are equivalent to each other, then since their bases are equivalent, we can simply set the exponents equal to each other, which would be how we show that x equals 3 in this case. That truly is what that's all the one-to-one property is. Now the one catch with the one-to-one property is you do need to make sure that all you have is a single term on both sides of the equation. Meaning, like, if you simply add a +1 over here, now suddenly the one-to-one property doesn't work and we can no longer solve this out the way we had just said. So you need to make sure you only have a single term on each side for this to work. But to show you an example where this is a little bit more involved, let's say that we had an example like 25 to the 3x power equals 125 to the x plus 2 power. And so looking at that right now, that looks like we can't solve that, or at least not off the information that I just gave you. But if we could find a way to rewrite these two sides, these two terms, down to the same base, then we could use the one-to-one property. For example, in this scenario, you might notice that 25 could be expressed as 5 squared, and 125 is the same thing as 5 to the third. So if I were to show that, and write this as 5 squared to the 3x power equals 5 to the third to the x plus 2 power, well then now what we've done is we've created an equation where we have a single exponential term on either side of the equal sign and their bases match up. The question then would be, we seem to have too many exponents here. We seem to have multiple exponents going to the same base. How do we combine those? Well, if you all remember from our properties of exponents video, when we have two exponents going to the same base, we are supposed to multiply those two exponents together. It's a power of a power. Meaning, this would be 5 to the 6x power, 2 times 3x. And this would be 5 to the 3x plus 6 power. Because remember, if we're taking 3 times the quantity x plus 2, that would be a distributive property. And now, like I already showed you with the one-to-one property earlier, since both of those bases are 5, we can simply ignore the bases and show that or set these exponents equal to each other. And what we see now is we've basically created a reasonably simple linear equation that we should be able to solve out. I would want to get all my x's on the same side. So for example, I could subtract 3x over here. 6x minus 3x is 3x, and that is equal to just 6. And now to get x completely by itself, I would simply need to divide by 3 on both sides, giving us a final answer of x equals 2. That's how you can use the one-to-one property to solve exponential equations. Let's look at another example here where we have two exponential terms. This time we have bases of 1/2 and 4. Now at first glance, it may not seem like this is something that we can rewrite to have the same base. But, again, if you remember our properties of exponents video, we did talk about a property that dealt with negative exponents. Negative exponents cause us to effectively get reciprocals. They cause us to flip our base. Meaning, 1/2 is the same thing as 2 to the negative first power. 2 to the positive first power is just 2, so 2 to the negative first power would be the reciprocal of that, or in other words, 1 over 2. So if we write this as 2 to the negative first to the x plus 7 power, and then if we rewrite 4 as 2 squared to the 3x power, now we have the same base on each side. I do need to combine these exponents again because again I see that I have multiple exponents going to the same base. So just like we talked about before, power of a power property says we need to multiply these exponents. So on the left side, I'm taking -1 times the quantity of x plus 7, meaning we would have 2 to the negative x minus 7 power. On the right side, we're simply just taking 2 times 3x, which would give us 2 to the 6x power. Again, since the bases are equivalent, we can just set the exponents equal to each other. And again, we've created a pretty straightforward linear equation. We could add x to the other side, giving us -7 equals positive 7x, and then simply divide by 7 to get x equals -1.